Hey everyone, my name is Scott, and we're going to solve the flipping an image problem on LeetCode. The problem definition is we're given a binary matrix, and we want to flip the image horizontally, then invert it. Flipping horizontally means we take each row, here's a row right here, 1, 1, 0, and turns into 0, 1, 1. We just flip it horizontally, we basically reverse it. Inverting an image, each 0 is replaced by a 1, and each 1 is replaced by a 0. So we're given a matrix and we have two transformations that we need to do on it. And we can do these transformations at the same time as we are looping through the matrix. Okay? So the first thing you need to realize is each of these arrays right here, it's kind of its own problem. We basically just have to reverse each array in the matrix as we traverse it. And then flipping it's pretty easy to do at the same time because we would just reverse and then flip from 0s to 1s and 1s to 0s as we're going. So let's go ahead and implement it. I'm just going to loop through the matrix. So if you don't know how matrices sort of work, it's basically an array of arrays. So by this loop right here, I call the index row to represent that we're looking at a row at that integer. And we loop up to this a dot length, okay? And a's length, the matrix's length, is the number of rows in the matrix, okay? And what I'm going to do is I'm going to pull out the current row by referencing a of the row index. I'm going to set up a low pointer and a high pointer. Okay, so I'm looping through this matrix. I'm looping over all the rows in the matrix, pulling out each row, and then setting a pointer to the beginning of that row, and then a pointer to the end of that row. Now, while the low pointer less or equal to the high pointer, what am I going to do? Well, I'm going to go ahead and write this down here at the bottom. Low plus plus, high minus minus. That way, our while loop doesn't run off without us. So what are we going to do? Well, I'm going to grab an integer called low I, which is going to be the current row at the index of the low pointer, and grab what I call the high I, which is the current row at the high pointer. Okay, so we're looping over the matrix, looping over all the rows. We pulled out the row, and we have a pointer at the low and the high index, okay? So at all times, the low pointer and the high pointer are going to be pointing at the two elements of the row that need to be switched. They need to be flipped in order to reverse the row, okay? So we're going to reverse the elements, but we also need to invert them. So what we're going to do is we're going to say the current row at the low pointer, we're going to set that equal to if the element at the high index is 0, then we will set it to 1, okay? That's the inversion. If it's not, meaning it's a 1, we'll set it to 0. And then at the high pointer, we're going to set it equal to, well, if the low element is equal to 0, we're just going to do the same thing. We'll set it to 1. Otherwise, we'll set it to 0. So that's the inversion right there. And then down here at the bottom, we're just going to return a. This is one thing to note. They want us to return a new matrix. We can do this in place by just modifying a. There's no rule against that in the problem. And matrices and arrays, matrix is just a abstraction for an array of arrays. In Java in particular, are passed by reference. So when we pull out this array and we make changes to it, it's a reference to the array that we're passed, so we're modifying it in place. Let's give this a go, make sure that it works. Uh-oh. Hey, why didn't somebody yell at me about this? That's no good. We can't increment a matrix. That doesn't even make sense. That looks better. Okay, there's our accepted solution. So the problem was I had a++ right here, which obviously makes no sense. We're incrementing row. Okay. So pretty simple. All we do is we loop over the rows in A. We pull out each row. We set a pointer to the beginning of the row and a pointer to the end of the row. And while the low pointer is less or equal to the high pointer, we grab the element at the low pointer and we grab the element at the high pointer. And then we set the element of the row at the low index and the high index equal to the opposite of whatever is at the other end. Okay? So by doing that, we flip it horizontally and we invert it at the same time. Because we've switched the elements and we've also gone from 0 to 1 or from 1 to 0. Now, the only programmatic tricky thing going on here is this little stuff right here. This is called a ternary statement, and it's simply a shorthand for if-else. So, kern of low is equal to, well, what's it equal to? This right here, obviously, is a binary statement. It's kind of saying is height of I equal to 0. In the case that it is, then it gets set to 1. In the case that it's not, it gets set to 0. So it's a ternary statement. It's just a tricky, fun little way to shorthand an if-else statement. And it makes things look a little cleaner. So that's it for this video.